Hello everyone! In this video, we're going to deal with the wavelength of the wave. We're going to click pause to pause the wave. Assuming the background lines are approximately 1 centimeter apart, what is the distance between the two wave tops? Yes, it's 15 centimeters. The distance is the wavelength lambda, and the wave tops are called crests. So, the wavelength is 15 centimeters. What is the amplitude of the wave? We defined previously the amplitude as the highest displacement of a particle from its rest position. So, from this black line, right here, to the top of the crest, it's about 5 centimeters. Now, we're going to move the wavelength slider to the far left. What happens? Yes, the wave crests get close to each other. And what is the wavelength now? Yes, it's about 10 centimeters. Now let's play the wave, and we're going to move the wavelength slider to the far right. And we will pause the wave. What is the wavelength now? Exactly, it's about 20 centimeters. And what is the amplitude now? Yes, it remains 5 centimeters. Have you changed the energy carried by the wave? Explain your answer. Well, the energy carried by the wave have not changed, because the wave amplitude have not changed as well. Now we're going to move the wavelength slider back and forth through its range. If this were a radio wave carrying energy to you from a transmitter, you would be tuning into different radio stations by changing the wavelength your radio was receiving. You may have heard of shortwave, medium wave, and long wave radio bands. These names refer to the wavelength range of the waves.